We're going to walk through how to add fractions, the process we use, and what that looks like. Hopefully, after seeing this, this will help answer some of your questions. So the problem we're going to look at is we're going to start with 2/4 plus 3/7. So the easiest way to find our least common denominator is by skip counting. We can do this by skip counting. We can also do this by looking at our multiplication chart in either the rows or the columns of 4 and 7. So for this, we're going to skip count. So what I'm going to do is I'm going to go through the first 5 of each to see if we can find a common denominator. So if I skip count by 4, I've got 4, 8, 12, 16, and 20. Now I'm going to skip count by 7 to see if we can find a common denominator in the first 5 here. So 7, 14, 21, 28, and 35. So nothing yet. I noticed that I'm a little bit ahead in terms of numbers down here, so I'm going to continue up top with my 4s to see if I can find a common denominator here with that. So I go 24, and then 28, and the one thing I notice right now is both 4 and 7 are going to share 28, and that is the first one they share, so the one we refer to as the least common denominator. So now what I'm going to do is I'm going to go down here and I'm going to rewrite my problem. So if I start with my first fraction, I've got 2/4. My other one was 3/7. Okay. To rewrite as equivalent fractions, we're going to look at this right here. So I need to know, how do I get to 28? So what am I going to multiply to get this in the denominator here and this in the denominator over here? Well, if I start right here, I look up top and I know that 4 times 7 is 28. So I need to multiply this by 7, which means if I multiply the bottom by 7, I have to multiply the top by 7. So I know 2 times 7 now is 14. If I go over here, 7 times some number is 28. And if I look up top, 7 times 1, 2, 3, 4. So 7 times 4 is 28. And whatever I do to the bottom, I have to do to the top. So now I've got 3 times 4, which is 12. Now I've got two fractions, both with a common denominator. And now I can go back down here and rewrite and solve. So I've got 14 over 28 plus 12 over 28. When we add or subtract fractions, all we're doing is going across our numerator and maintaining the same denominator. So this right here is not going to change. So I'm just going to go ahead and rewrite this right over here. We're not adding these two together. We're just bringing it along over here. Now I'm going to add my numerator together, though. So 14 plus 12, I know that that's going to give me 26 over 28. Our last step is simplifying if we can. So if I rewrite this down here, 26 over 28. The way I determine if I can simplify is I'm going to list my factors for each number. So I'm going to start by 26. I know I've got 1 times 26. I've got 2 times 13. 3, no. 4, no. 5, no. 6, no. 7, no. 8, no. 9, no. 10, no. 11, no. 12, no. And then I'm back here. So my factors of 26 are just 1 and 26 and 2 and 13. Now if we think about 28, again, you can use a multiplication chart. This makes that a little easier. We got 1 times 28. I got 2 times 14. 3, no. 4, yes. 4 times 7. 5, no. 6, no. And then I'm back to 7. So if I look at these two numbers, a common factor that they share is 2. So we're going to take each of these and divide it by 2 to get our lowest common fraction, or a fraction in lowest terms. So 26 divided by 2 is going to give me 13, and 28 divided by 2 is going to give me 14, and that is our final answer. All right, let's look at another example. So if I have 2/5 plus 3/7. So again, we follow the same rules we did up top. If I think about my denominators, I've got 5 and 7. I'm going to skip count by 5 and skip count by 7. Or if you have your multiplication chart handy, look at those, your rows or your columns, to see which is the first number that these two share. So if I skip count my first 5 here, I've got 5, 10, 15, 20, 25. If I skip count my first 5 of 7, I've got 7, 14, 21, 28, and 35. And again, if you notice, in this case, again, I'm a little bit ahead in terms of how far I've gone with this bottom number, so I'm going to try and catch up top to see if I can get something around there. So if I continue to skip count by 5, I've got 30, and then 35. And if we notice, the first number that these two share is 35. So that is going to be our least common denominator. So I'm going to go down here. I know that I need to rewrite this like this and rewrite this like this. Actually, whoops. Let me go back here. So my original fraction was 2/5. My other fraction was 3/7. We're trying to get to a common denominator of 35. So we say, what do we need to multiply to get to 35 in this case? So 5 times 7. And again, whatever you do to the denominator, you have to do to the numerator. So we're going to multiply the numerator by 7 as well. So 2 times 7 is 14. If we go over here, we say 7 times what is 35? Well, it's just flip-flopping these. So now I know that 7 times 5 is 35. Whatever I do to the denominator, I have to do to the numerator. So I'm going to do that up top and say 3 times 5, which is 15. So now I have two equivalent fractions and can rewrite them down here below and hopefully solve. So 14 over 35 plus 15 over 35 And again, so I'm going to immediately rewrite my denominator over here. This is not going to change. Okay, we don't add these, we don't subtract these, we just bring it over. And then we're just going to add our numerators. So we've got 14 plus 15. If I add those together, I know that that is 29. And then we come down here to see if there is any way to simplify this. So again, to simplify, we have to think about our factors of each number. So our factors for 29, in this case, are just 1 times 29. So where I know that the only two factors for 29, there's nothing else that multiplied together would equal this, that I don't need to go through my factors of 35 because the only thing that they're going to share is 1. And since 1's the only one that they're going to share, it's not going to change how we reduce. So our final answer, in this case, of what was originally 2/5 plus 3/7 would be solved to be 29 over 35. So 2 examples. The first showed you how to get your answer and then reduce. The second one was already in lowest terms and couldn't be reduced. Hopefully that this helps you. The same rules would apply for subtraction. You would do the same process. The only thing that would be different is this part right here, and we'd be subtracting instead of adding. Hope this helps, and we'll keep working to improve our ability to add and subtract fractions.